Hi, and welcome back. I'm Hank Preston, a developer evangelist with Cisco DevNet, and I'm here to talk to you about learning to CRUD with Git, Post, and Delete using RESTconf. This is a portion of our Network Programmability Basics video course, and we are in the Network Device APIs module of content. We have already covered getting the yang of it with standard data models and looked at netconf and goodbye SNMP, hello netconf. And in this lesson, we're going to look at RESTconf, the newest kid on the block as far as standard protocols for model-driven programmability. If you want to follow along with me during this lesson, by all means, please do. You can get the code and all of the information necessary to execute the labs and exercises up on GitHub. You'll find it in the Cisco DevNet organization and the netprog_basics repository. Each lab, including this one, includes a README that details all of the prerequisites and setup instructions to get your workstation ready to go. And when we've got infrastructure necessary to run the labs, you can find access to how to access and information on which DevNet sandbox you should reserve to get started. Let's dive right in. So for the RESTconf module, we're going to once again start out with the road to model-driven programmability. What is model-driven programmability? What are the elements included, and why should we care? After that, we'll look at RESTconf as a protocol and some of the details on how it's put together. And then we'll look at how we can use RESTconf along with Postman, an excellent tool for dealing with REST APIs. And at the end, we'll look at how we can actually use RESTconf to interface with our network and go ahead and retrieve and configure information about our interfaces. So the road to model-driven programmability. Now, if we think about where we've come from in the network, it used to be that the only folks interested in manipulating, configuring, or checking status of the network were network engineers, and we were more than happy just to use the CLI that was provided. But that's not the case anymore. Whether we're talking about cloud use cases, web applications that want to get information from the network, or DevOps operations that are trying to bring the infrastructure and the network into the operations future, we need requirements such as REST APIs, Ansible playbooks. We want to have good data formats like JSON and XML and move away from text-based use cases for display of data. And so the CLI just no longer fits the need. We needed a new way to interface in a standard programmatic fashion. Now you may be asking yourself, Hank, we've had SNMP. Why doesn't SNMP fit this area? Well, frankly, SNMP works reasonably well for monitoring. If all you're interested in is the health of the network, counters, statistics, information about how things are going, SNMP has suited us. But very few users are actually leveraging SNMP for configuration. Sending configuration details require writable MIBs that we just have a good lack of out there. And then all of the security concerns that SNMP has had for a while. We've solved many of them, moving from V1 to V2 to V3, but many people are still back on some of the previous versions. And so when the industry got together of network engineers, vendors, partners, consumers like yourselves, we've come up with this concept of model-driven programmability in a new standard fashion. And with model-driven programmability, we take a step back and we say, we will have our device features inside of our infrastructure, but we want to model those. We want to have an articulate way to identify the configuration and operational details. And we want to have standard-based, as well as the vendor-specific elements of those, all done and provided in a yang data model format so that we can transport those and work with all of the information in the network, be it configuration or operational, in a consistent programmatic fashion. And then to expose those data models to the outside world, we want to have an opportunity to use multiple protocols. Originally, we had netconf back in 2006, and then just at the beginning of this year, in January of 2017, RESTconf was standardized fully. The team over at Google have an open source project called gRPC, which is not specific to the network, but is another interface where we can get access to the yang data models that are there. In this session, we're going to talk specifically about RESTconf as that transport protocol. Speaking of transport protocols, let's dive in and distinguish between the transport protocol, which is RESTconf for this lesson, and the data model that articulates and identifies all the information about the network that we're working with. That would be yang. When we think about how we transport communications over the network in typical client-server fashion, we have to communicate with Ethernet and IP and over protocols like TCP or UDP. That element, how we actually communicate over the network to the device, that's the transport protocol. And that's where RESTconf along with netconf and gRPC fit in. Now all of those will access and give you access to the same data in the network all modeled by those Yang data models that we talked about in a previous lesson. So whether you're using RESTconf in this lesson or netconf before, we were using the exact same data, and it's up to the developer or you as a network engineer to choose which one you're more comfortable with for a particular use case. Now RESTconf. We've talked about netconf already, so where does RESTconf fit into this? Standardized in January of 2017 with RFC 8040, RESTconf is an HTTP-based protocol to provide a programmatic interface for accessing all of that Yang data, almost word for word quoted right out of the RFC. What that means to us is it provides us a REST API-like interface to work with our infrastructure in the network layer. We were using REST APIs, and the value of a REST API is its portability, its simplicity, and its ease of use that's there. And RESTconf brings all of that to us in the network space. RESTconf builds on top of HTTP, but primarily we'll use HTTPS to make sure that we're secure in that transport that's out there. And one advantage that RESTconf offers for many developers over netconf is the fact that it supports both XML as well as JSON, which tends to be the primary and preferred data format for most developers today. So what about netconf? With the launch of RESTconf, does that mean that netconf goes away? No, it won't. What we will probably see is, depending on the use case, we'll still see netconf and RESTconf both used. Network management systems, streaming telemetry services, areas that want to have robust support of all of the model-driven programmability that's there, still will use netconf because it has a more robust feature set than RESTconf does. But network engineers looking to grab basic information or retrieve information and configure their infrastructure using those REST API skills that they've built up, or web application developers looking to get information about the network, they may prefer to use RESTconf because of its similarity to the other API styles that it's using. Now, just like netconf had a transport protocol stack that we looked at, so does RESTconf. It is a simpler stack. We've got 3 layers that we want to talk through. Now, as I've mentioned a couple of times, RESTconf builds on top of HTTP, and so it uses all the same TCP and IP methods that are available there. So everything we've learned about the REST APIs that are out there are related to headers and methods, verbs, URI construction, and how all those go. They will translate directly into our RESTconf discussion today. Now, from an operations perspective, we're using the same verbs and methods that we saw with HTTP. So we'll talk about how get, post, put, patch, and delete fit into our RESTconf discussions. And then once we send, or once we retrieve, or when we want to send data out to a RESTconf agent, we'll use XML or JSON as our choice will dictate on there. Now, speaking of operations, let's talk about how the RESTconf, the CRUD operations from RESTconf map into the different netconf operations that we learned about. A RESTconf GET request will give us the ability to both leverage the GET or getConfig netconf operations for configuration and state data. If we want to do a create operation inside of a RESTconf call in order to create a new interface or new object inside of the data model, we would use post. Put gives us the ability to also do an edit config, but in this case we're either creating or replacing data that's inside of the data model currently. If we're looking to merge information, we're not sending the full data we're not sending a full data block related to what we want to configure. We just want to send updates to it. We can do a merge using the patch operation or the patch method inside of RESTconf. And then finally, when we want to delete information from the data model, we would use the delete action, which corresponds to an edit config with an operation of delete inside of netconf. Now, from a content perspective, I've mentioned a couple of times that RESTconf supports both JSON and XML. And the way that we define to the RESTconf agent which one we're interested in is using headers, just like we would expect with any REST API. But we do have to recognize that the headers that you will use are slightly different than you may use in other REST APIs. It's not a simple application/JSON or application/XML. We have to use new MIME types that were defined as part of the RESTconf standard. And so we'll have application/yang-data, and then if we want JSON, plus JSON. If we want XML, it'll be plus XML, giving us the ability to define what information we're sending or what information we would like RESTconf to send back to us. In these examples, I personally prefer JSON, so in our examples here we'll use JSON, but in any of these you can just switch over to plus XML instead if you prefer the XML output for consistency with netconf. Now, what about the URI construction? How do we actually construct the URI based on those Yang data models? Well, here's the little cheat sheet and legend that I've constructed for you all to kind of keep up on your bulletin board to go through. So let's walk through it. So we'll start out with HTTPS, In some of the earlier draft versions of RESTconf, it was supported over both HTTP and HTTPS, but now that we've standardized, we are moving solely just to the secure version of HTTP, so make sure you're using HTTPS. We'll then provide the address of the RESTconf agent that we'll connect to. Typically, that'll be the IP address of your switch or your network management service that's providing the RESTconf capability. Now, if your RESTconf agent is running on the standard HTTPS port of 443, then you don't have to specify it, but if your agent runs on a separate port, you would include that as part of the address. Following that, we get into the actual resource information for RESTconf, and that starts out with a root element inside of the API call. Now, typically, that will just be RESTconf. However, if you need to discover that, you can do that for using a well-known element, a well-known API request from the agents that you're connecting to, which is specified inside of the RFC. So if you send an API call to your host.well-known/host metadata, you will retrieve back a blob of information that specifies exactly what is the root. Although you can probably start out with just using RESTconf because that likely will be what you need. Following the root of the API call, we have the data store shown here into the slide in red. Now, data stores inside of a Yang and RESTconf correspond to running or operational data or configuration data. Now, you can just use, and we'll see how we use within iOS XE and some of these other areas, just the word data to indicate that we're after to retrieve back to give a generic data store source. In yellow, we get to the point where we identify the specific model and container information we're interested in. And so we specify that with the model name, the container inside of the model we're looking for. Now, RESTconf specifies that the Yang model could be omitted. That's an optional parameter, in which case the RESTconf agent will deduce which model you're interested in based on the container name that you provide. Lastly, we end up in purple here with the leaf. Which element from inside the container are you interested in? Now, if that leaf is part of a list and you need to specify a specific element, you would say the leaf equals a particular instance of the name. We'll see examples of that when we pull information about network interfaces off of a router. And then lastly, we can support options inside of RESTconf that give us the ability to determine what level of depth we want to navigate down the data models on that. Do we want just the specific Yang model that we've requested, or do we want to see all of the nested models that might be included as part of the contents that are there? Now that we've seen the kind of the cheat sheet and the legend of how to construct it, let's actually take a look at a data model and see how that would map into a specific URI. All right, so here now we're looking at an actual RESTconf URI request, and let's figure out how we map in the different elements that we talked through. We'll start out with an address and then the RESTconf/data to indicate the root and then the data store that we're interested in, and then we move on from there. So in this case, we're looking at the IETF interfaces module, so we're going to go ahead and specify that inside of the URI. And then the container that we're interested in is the interfaces container, so we see how that fills in as well. Now we're looking at the interface leaf, so we then specify that. And because this is a list object and we need to key off a particular name, we would then provide the name inside following the interface equals element of this. This lets us drill into specifically which interface inside of the data model that we're interested in. Now we end in depth equals unbound, and what that does is that is the default, so we wouldn't have to necessarily specify that, but I explicitly called it out here so we can talk about it. What depth equals unbound means is as it returns back the data related to this data model and this bit of information inside of the system, if there are any included information or included data models that are in there. In this case, a gigabit Ethernet return data will also include information about IP addresses. Without depth equals unbound, or if we were to do depth equals 1, we wouldn't see all of that nested IP information returned back from the RESTconf call. Now again, depth equals unbound is the default, so you don't have to specify it. But if you are interested in just a single level of depth, or you want to dive down 2 levels of depth, you can do that with integer pieces that are there. Now that we've talked through how we would actually see the fundamentals of RESTconf, let's see it in action using Postman. As a reminder, Postman is a powerful but simple REST API client that's available either as an application or a plugin to web browsers like Chrome. And it gives you the ability to save APIs into collections and set up environments and auto-generate code. We talked specifically and spent a good amount of time inside of the Programming Fundamentals module looking at how we would use Postman in a general fashion, and now we're going to put it to use using RESTconf. So we'll start out by setting up our environment for RESTconf. So our environment in this case is going to point at a particular device, a network device that we're going to make our RESTconf calls against. And so we set up in our environment, we set up variables for host, for port, username, and password. In these cases, these correspond to the DevNet sandbox that we're using for this lesson. Now with those created, we'll be able to use those inside of the Postman REST API calls, inside of address bars, as well as inside of authentication information, as we can see on the slide here. Moving ahead, let's go ahead and start out with the process. When we work in model-driven programmability, whether we're using RESTconf or NetConf, the first thing we want to understand are what capabilities are supported by our device. And so we can send a GET request to RESTconf/data netconf-state capabilities, and that is one that'll map to any RESTconf to device to return back all of the capabilities that are supported by that device that are there. We can see that in Postman boxed off in green. Once we have that, we want to add the RESTconf headers that are necessary. From an authorization perspective, we're going to use basic authorization, and we can see it boxed off in yellow, where we selected basic and provided links to the variables for username and password that we set up in the environment. And then for the accept and content type headers, I'm going to prefer JSON, so I'll use the application/yang-data plus JSON inside of the headers set up inside of Postman. If you are an XML kind of guy, feel free to use XML instead. Now with those configured, we can go ahead and move ahead, and we can send and review our results. And this gives us back inside of the Postman window the full list of all of the capabilities that are supported. Let's review the capabilities information that we talked about prior in the NetConf session. And so the capabilities list as we see it are broken up into two generic types, or general types of capabilities. Boxed in blue, we can see the general NetConf capabilities of which versions of NetConf are supported. We are working with RESTconf, but this is building on top of what NetConf is supporting out there, which is why we see those referenced here in the capabilities. And then we see the list of data models that are supported, and I've edited it down here so that we can fit it onto the slide. And we can see that IETF interfaces, as well as an iOS XE native data models that are supported. Inside of that capabilities list, we'll see all of the standard as well as the vendor-specific data models supported returned from that RESTconf call. Now, when we want to talk about the capabilities, specifically the data models that are supported, we need to be able to break down the full information that is returned by the device. So the first bit of that in blue is the model URI, the unique identifier that specifies this capability inside of the device. Now, remember, even though sometimes they may look like a URL, as we can see in the second one on the list here, http://cisco.com/ns, just because it looks like a URL, they are not designed to be web resolvable URLs for information. It's just a unique name for it. In yellow in the callout here, we can see the module name and revision date. These are what we're going to refer to that module name as. And if we want to go back and look at which version of the module that it was standardized and we're based on, you can see that by the revision date. In green, we have protocol features that are supported by this model. And then lastly, in red, we see the deviations. If the implementation of this model on the device has some changes from the basic standard, the deviations will indicate what those are. All right, now that we've talked about the fundamentals of RESTconf, let's look at how we can use it to automate our network. Now the first bit that we're going to do is a basic operational information. We want to get information about an interface detail that's out there. And I say I want to get the information, and indeed that is the type of RESTconf request we're going to use. We will get our information, and we're going to get that about the IETF interfaces module, the interfaces container, and explicitly the gigabit Ethernet 2 that we've got from our device. When we send this request after configuring the authorization and headers, we can see the data that's returned inside of Postman based on our interface. Now in this state, we see that we don't have a lot configured on this interface. There's no description, there's no IP address information that are there. So let's look at how we can use RESTconf to configure that by putting it up inside of the router. And once again, we are going to use put. So in this case, now we're going to switch from a GET request and use the new method of put. Now the actual URI will be the same. This is one of the things that's nice about most REST APIs, is that when you move from retrieving data with GET to updating data with put or post, typically the REST API, the actual URI call itself can stay the same. What we're going to update is the actual body. Because this is a put, we have to send data. And so we start with the information that we retrieve from the GET request, and we put that into the body of Postman, and we add in the details we want to update. In this case, we can see with the blue arrows, I'm indicating a new description configured by RESTconf. as well as adding an address inside of the IETF IP IPv4 information that's there, so we can configure an IP address. Once we have that configured, we can send the request and we can check the status code down in the bottom corner here, boxed off in red, and see that we have a 201 status code that came back, which indicates a successful creation. We want to verify that that information was done successfully, so we return back to our GET request and basically send that exact same request back as a GET. But now we can see, as pointed out with the blue arrows, that our description and IPv4 address are indeed configured. We've been able to use RESTconf to fully query interface state, update our interface configuration, and now actually verify that those changes were there. So in summary, what did we look at with RESTconf? Well, we started out going back and trying to figure out and understanding where is model-driven programmability coming from and why do we use it? And what are the key elements of the data models provided by Yang and the different transport protocols of netconf and RESTconf we may choose to use. We dove into RESTconf as the transport protocol to understand how the transport works over HTTP, how to use the methods, and then how to work with headers and data that are in there. After we had that basic fundamental knowledge, we used Postman to configure our network interfaces with RESTconf data models that were out there. Now, call to action. As you finish this video up, make sure to go ahead and run those exercises yourself if you didn't do them along with me. Also, check out the entire Network Programmability Basics course. We've already covered data models, the data model-driven programmability in device layer APIs, and we'll be back to look at specifically the NX API as another alternative to configure your Nexus switches using device-level APIs. We've got modules covering all sorts of other topics such as application and hosting and net DevOps coming up as well. And be sure to join me up on DevNet at developer.cisco.com, where you can gain access to all of our learning labs, sandboxes, sample code, and other information that's available. If you have any questions, feel free to come find me directly. You can hit me up on email or Spark at hapresto.cisco.com. I'm available on Twitter at hfpreston. You can follow Cisco DevNet on Twitter, Facebook, and other social media platforms at Cisco DevNet. And follow all of us up on GitHub, where you can find tons of sample code, examples, and use cases for network programmability, as well as lots of other topics that are out there. Thanks so much for joining me on this video lesson covering RESTconf. Up next, we'll be diving into NX API and how you can use it as an alternative to configure model-driven programmability in your Nexus switches. Thanks, and see you soon.